So 4-2 is going to be on law of sine. 4-2 is law of cosine. So let's say y'all, especially the formula for law of sine, you're not trying to get law of So when we use the term solve a triangle, that means find everything that's missing in the triangle. Okay? So let's look first on laws of sine here. Okay, and then I'll tell you a little bit about laws of cosine, but not get into too much depth here. So laws of sine is this formula. You do A over the sine of A equals B over the sine of B equals little c over the sine of c. And so what you do is you use like a naming system with your triangles that little a is like the side of the triangle, and then big A is the angle that's across from that side. Now, the way our textbook does it a little bit differently here is they don't use capital letters for the angles. Instead, in our dual enrollment textbook, they use the Greek letters. So they use alpha, and then they use beta, and then for this one, for C, they use gamma, which looks like that. It's like a Y with like a computer or something. That's the best I can do is draw the gram. Okay. Yeah, I'll make you get it. Okay. Now, and so the idea is what we do is we take the information that we know and we fill it in and we just cross multiply to solve for the stuff that we don't. It's real simple. Okay. Now, the cases that you use for laws of sine would be if you're given two angles and a side. So that would be angle, angle, side, or angle, side, angle. Okay. Now, there's one more case, and we won't talk about this case today. We'll talk about this case actually on Wednesday the next time that we have a lesson. Okay. So the third one is the bad one backwards. And if you look at it backwards, it's bad. And frontwards, it's bad too. All right, side-side angle, and I always put an asterisk beside it because it's called the ambiguous case. And so what you have to do with side-side angle is you have to determine how many triangles that you have first. It could be that it couldn't make a triangle, it could be that it could make one triangle, or it could make it two triangles. And again, that's just going to be the next lesson. Okay, so that's the part of lesson 4.2 that I'm putting off. Okay, we're only going to talk about these two cases today. Okay, so the other one, it's the bad one, we'll kind of get to later. Now, just to give you some reference here about, you should be thinking ahead, you also have laws of cosine. Now, I'm not going to show you that formula, but the cases that you use for law of cosine, you probably need to go ahead and start learning these. For laws of cosine, you use for side, 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 and side, angle, side. So all this angle, angle, side, and angle, side, angle, that would be like the given information, the stuff that they gave you. So if they gave us two angles and a side, which is what we're going to look at today, you use law of sines. But if they give me all three sides, that would be side, side, side. If they give me side and the two sides and the included angle, then I would use law of cosines. Now, do y'all know the difference between side, side angle and side, angle, side about where the angle is located in geometry? In this case, this angle is the non-included angle. So that means it's the angle that's not in between the two sides. So the angle would not be in between. Okay? In this case, the angle would be the included angle, so it would be the angle in between the two sides. Okay? When we start looking at this, especially on Wednesday, I'll kind of give you a better explanation about side-side angle and how it's different from side angle side. All right, but for today, let's just go with these two. Okay? And we're going to use laws of sine. Now notice it's a pretty simple formula. You do have to memorize it, but it's really easy to memorize. Now in your textbook flips those. It puts the angle, the sine of the angle on top and the side on the bottom. So I've never done it that way. That's the first time I've ever seen it done that way. I'm not going to do it the way they did it. like I've always done. All right, now, all right, so let's look at this. It says solve the following triangle. So again, that means to find everything that's missing. Okay, now, so they give you a picture to go by. Now, so notice what you have. Alpha is 20 degrees, and little a is across from that, right? So little a is going to be across from alpha, right? Little b is going to be across from beta, and then little c is going to be across from gamma. Now, there's something there that, we don't really need trigonometry to solve. What's that? The gamma. Okay, we solve for the gamma. Is what the angles in a triangle have to sum up to be 180. All right, so you got 20 and 50 would give you 70. So gamma up there would become a 1/10. Okay. All right, so we've got, and I think that usually they'll have 3 parts to this one. That would be the first part. Okay. Now the second part is going to be to find sides B and C. So what I'm going to do is fill in my law of sines. Now, always start here with the one that I'm giving both the angle and the side. Let's do the ratio here where I have the angle and the side. It's going to be the alpha, the beta, or the gamma. Alpha. Okay, so you notice how you have little a and you have alpha. All right, the side, and then the angle across from the side to give it both. So we're going to do a over the sine of a, or in this case it would be a over the sine of alpha. So that would be 4 over the sine of what? 20. Okay, and so this should be equal to, now let's set up the other two. Okay, so give me another ratio where you do the side on the top with the sine of the angle on the bottom. B over sine of 50. Okay. And then the last one would be C over sine of 110. Now, you'll notice how that you're given the first ratio there. Okay, you have both things. So this first ratio is what I'm going to use to cross multiply to find both the other two sides. Okay, so I'm going to take these two and cross multiply, and then that can help me find B. Now, each calculator, be sure it's in degrees. Okay, so all our answers are in degrees. So I'm going to cross multiply. We're going to do B times sine of 20 equals 4 on sine of 50. Okay, so how would we solve for that? Right. Yeah. Now, got everything canceling, so you got B over here. Now, get all in there. 4 sine 50 divided by sine 20. So, I can't remember how many decimal places they've asked me. I don't know if it was 1 or 2. Let's just say 1 decimal place. So there's 1 decimal place that round up to 9.0 to go get that. So it would be about 9.0. Okay. Now, let's find C. Now, I'm going to find C the same way. But what I'm going to do to find C is like just cover up that middle ratio. And so I'm still going to cross multiply with this, except for I'm going to cross multiply with that one and then that one. Alright, does that make sense? Right, the first and the third. Now, what you could do is you could put 9.0 right there and cross multiply with that. But what's going to be an issue with that? It's going to be right. It's going to be a little bit off because 9.0 is not exact, was it? Okay, so you're going to have to stay away from that.
I thought it was supposed to be in there.
Sure. Now, all right, let's cross multiply again. Like I said, with that first and third. So this would give me 4 times sine of 110 equals C times sine 120. And just, oh, here. All right, now how would we solve there? By sine 20. So when we divide that out, let's see what happens. 4 sine 110 divided by sine 20. Alright, so yeah, it's about 11.2. Okay. Alright, so, I mean, does that seem fairly simple? It is. Because honestly, you know, when we did this with honors, they did really well with it. And that's only going to be with these two cases. Okay? Angle, angle, side, and angle, side, angle are going to be really, really simple cases to do. Okay? Let's probably start off with these and kind of work up to the harder ones. Now, for those three, okay, for these three, angle, angle, side, angle, and side, angle. Okay? But there again, I'm going to have to really focus on that one on a whole different day because you have multiple triangles. Okay? So, and usually what happens is when you have the two triangle case with side, angle, it's the worst. Because you have to not only solve for one triangle, but you have to solve for both triangles that you would get. Alright, there again, that'll be on Wednesday. Now, so on this one, again, I've got two angles and a side. So it's either going to be angle, angle, side, or angle, side, angle. Now, can we skip this one, or do you want me to work it out? Can we work it out?
Yeah.
Okay. Now notice I don't get a triangle on this one, do I? I guess I have to draw my own. Alright, go A, B, C. Alright, so we got A is 20 degrees, B is 50 degrees. And so, where's the 4 going to go at? Yeah, opposite of angle A. So at the bottom. Okay. Now, you should be able to tell me immediately what C would be. You have 110, right? 20, 50s, 70, 180 minus 70s, 110 there. Okay. Now, did y'all notice how that was angle, angle, side? You had two sides of the angle. Now, so that means we would use laws of sine. Okay. So notice on this one, they don't use the Greek letters this time. They use the capital letters. So we do A over sine of A equals B over sine of B equals C over sine of C. So A over sine of A would give me 4 over sine of 20. Okay, and then B over sine of B. Now where would little b?
On the AC side.
All right, on the AC side, so right there would be little b, and then right here would be little c. All right, so B over sine of B, so it would be B over sine of 50. And C over sine of C, so it would be C over sine of 110. Is that the same as the last problem? Because little a is across from big A. Okay? Was that really the same as the last one?
Yeah.
Okay. Well, let's just skip it then.
Thank you.
Okay? Huh? Alright, because look, what was given was this angle, and this side, right? So that would be angle, angle, side. Now, what's the difference in angle, angle, side, and angle, side, angle? The side would have been in the middle. Okay? So if this 4 would have been here, that would have been angle, side, angle. But really with angle, side, and angle, side, angle, it doesn't matter because you're going to use laws of sine anyway. Okay? Alright, let's just skip. Go to the next one. It's going to be in the same more than me. Alright, now, from here we're going to look at basically the word problems. Okay? And they're really not that bad. Now, let me read through it here. You can kind of look at the picture. They do give you a picture to go with it. Alright, it says the Coast Guard Station Able That's that one that's down at the bottom. It is located 280 miles due south of Station Barton, the Baker. Okay. A ship at sea sends an SOS call that is received by each station. Right, so you see the little ship on the right there? So I guess it's like sinking or something. All right. So they call to Station Able, indicates that the ship is located north 55 degrees east. And then the call to Station Baker indicates the ship is located south 60 degrees east. Okay. So the first question, this will be a two-part. Okay. It says, how far is each station from the ship? Okay. So what we're looking for over here is this distance, this one. Okay. So let's do this one. Let's call this down here A for Able, and then B for Barker. We could call the other one C. You want to do that? And so, what are they really asking for just on the picture? How far is each station from the ship? The two sides. Okay. So, what can we call this side?
A.
Little a. And then we call this one little b. Okay. Now, you see how we could set up a law of sines proportion to find those two sides of that triangle? So that would answer that question there. Now, we probably need to find something first before we set up law of sine there.
The angle.
Angle C. So 60 and 55 would be 115. 180 minus 115 would be 65. Okay. We got angle C there. And 65. Okay. Now, so let's set up our laws of sine. Now, you don't really have to do them in order. I mean, you can give the proportions in any order that you want to. I always like to make the first one be the one with the two that I know what they are. Okay. For instance, this would be the C one, because you know the angle and the side. Whereas on the other two, you're missing the side. So the ones I'm going to start off with is this one and this one, because I know both of them. Now, how would I write it then? Right. 280 over sine of 65 degrees equals. Right, now the other two wouldn't matter the order that you put them in. Okay, somebody else can do what now? We'll do that. Yeah. So we can do like A over sine of A. So it'll be A over the sine of 55. Okay. And then B over the sine of 60. Okay, now you see how that first one's going to find A and B? Now we'll cross multiply with the first ratio to get them. Okay, so let's cross multiply with the first two. It'll give me A times sine of 65 equals 280 times sine of 55. So how would I solve for that A there? Right. Well, that's sine of 65. Those are canceled. Now, 280 times sine 55. Sine 55 divided by the sine of 65. Okay, so I got about 253. Let's go to 2 decimals. 0.07. I don't remember how they say it around that. Just remember to read the directions and go to where it says. Now, you may want to do this. When we have to find something later, we're going to need this exact value to do a calculation. So you probably need to store that. Okay, you remember how to store them on your scientific calculator? All right. So STO, and then assign it. It'd be real convenient to assign it as A, right? And that'd be easy to remember that. Now, on B, find it. So we're going to cover up the middle when you cross multiply. That'll give me 280 times sine of 60 equals b times sine 65. So we divide both sides by sine of 65. Let's see, 280 times sine of 60 divided by the sine of 65 is about 267.55. Okay. So let's think about this realistically. Okay, which station should send help here? Able. Okay, because they could get there faster. So I think that's what the next question is going to ask. So I'm going to do this. I'm going to write in my numbers on my A and B here. This one's 253.07. Now I think that's going to be in miles. Yeah, because the 280 was in miles there. So this will be miles. And then this one's a further one. It's 267.55 miles. Okay. So you fill in those distances. They give you like 2 boxes to fill in there. All right. Now let's look at the next question. All right. I'll need my picture. Alright, it says if a helicopter capable of flying 200 miles per hour is dispatched from the nearest station to the ship, how long would it take to reach the ship? Okay, so notice it did say what the nearest one, right? And so the nearest one, I said it would be Able, it would actually be, it would be Baker, because I was thinking little a would go with big A, but Able would be further. Right. So the closest one would be the Baker. So I got to figure out if my helicopter is flying 200 miles per hour, how long is it going to take to get there? Okay. So we have a little helicopter here. That's a pretty good helicopter. All right. We'd have to fly to sea. Let's take it fly. And then rescue the ship. Okay. Now. So let's see, we should know a formula here, right? What? Distance equals rate times time. So the distance that they have to cover is the 253.07 miles. And the rate is 200 miles per hour, so 200 times t. All right, so divided by 200. And now, when you punch this in your calculator, you're not going to punch down what's right there. You're going to have to recall that 253 something. Okay? Now, on my 84, I have like a copy and paste function, so it's not hard on my 84. I don't have to store it or something. So that 253 something divided by 200. Okay? So, I'm not sure if they're going to ask it to the nearest tenths or hundredths. Let's just go to the tenths here. So that would be about 1.3 hours. All right, does that kind of make sense there? It's really not that hard of a problem because they draw the picture for you. They've got the picture laid out. So all you have to do is find the two sides of the triangle, and just basically use your distance, rate, and time formula to figure out how long it takes the helicopter to fly. You want to see the helicopter fly there? Just pick them up. Drop it. Okay. Alright, let's look at this. Alright, now here again you've got a picture, so it's not really that difficult. Alright, it says to find the length of the span of a proposed ski lift from A to B, the surveyor measures angle DAB to be 25 degrees and then walks off the distance of L, which is 1,400 feet, to C to measure the angle of AC B to be 15 degrees. So what is the distance from A to B? Okay, now let's fill in some stuff here. And so you notice we definitely have some triangles here. Now we might have to make us a right triangle, drawing that altitude straight down. Okay? But you should see an angle that you can find here. This one right here, 180 minus 25 because they form a straight line. Okay, so come on, bring that triangle out and draw it here. Alright, so this one's 15 degrees, and so this one will be what, 155? Okay, and then they said this down here, this L was 1,400 feet. Right, so the top of it would be 10 degrees. Okay, now let's find, what are we supposed to be looking for here? What is the distance from A to B? And so wouldn't that be that side right there that's missing? Okay, so I'm going to call that, what I'm finding there, X. Now, y'all see how we could use laws of sine here? We got basically angle side angle. Okay, so let's set up something with X. So what would I do? X over alright, sine of 15 equals 1,400 over sine of 10. Now we can cross multiply to get there. Right. So all I was looking at is that triangle that was on the right. Now, did you see how I figured out that that was 155 right there? So you had to find that angle. And from that angle, then you could find that angle. And see, that gives you enough to set up a law of sine. So let's cross multiply. Right, so we get X times the sine of 10 degrees equals 1,400 times sine of 15. So we divide both sides by sine of 10. Alright, let's see what this is. 1,400 times sine of 15 degrees divided by sine of 10. I got 2,000 and something. I think it's going to ask to go to here, split on this one. So 2,087 feet. So again, it's not really a hard problem because they kind of draw the triangles for you. They draw the picture of it for you, so it's not that bad. Now, we're going to look at another one. I think it's maybe the last one. Well, they'll actually have to find the height, and it's a little bit more involved. Let's see. All right. Here's sort of like an airplane problem here. And this is basically where you have two people. One's at alpha and one's at beta, measuring the angle up to the airplane. And ultimately, what you're going to be asked for is the height. Is that H thing there. Now, let me read through it. So it says an aircraft at sea is spotted by two observers at A and B. Okay, so there you go. We got one person over here looking up, and another person over here looking. Here's a good name. Right. And it says they are 1,500 feet apart. Or, excuse me, 1,400. As the airplane passes over the line joint of each observer takes a sighting of the angle of elevation to the plane as indicated in the figure. So notice they've got alpha is 45 degrees, and then beta is 40 degrees. Okay? How high is the airplane? Now notice if that's, you've got two right triangles there, don't you? So you can use some right triangle trees, but you don't have enough information there. So you've got together the two sides would make 1400, but you don't know them individually. So you couldn't really use right triangle trees yet. But we could use some laws of sine here to help me find one of those two sides. Right? And so picture it. If I knew what this side was, which would be the hypotenuse on that left triangle, that's the right triangle, then I could use my right triangle tree to find the height. Okay? So, but what am I going to have to find here to use law of sines here? The angle at the top? Yeah, 95. Yeah, 45 and 40 would be 95. Not 95 would be 85, I think. Y'all check here. The angle at the top is going to be 85 degrees. Is that right? Or would it be 95? No, it would be 95. 95 degrees. Okay. Now, y'all see how we can use laws of sine? So what I'm looking at is the big triangle. Okay, not the two little ones, but the big triangle. So let's set up a law of sines. Now, what's the ratio that I know? The 1400
over sine.
Right. 1400 over sine of 95 equals. And now you can either find the B or the A. We only need one of them. So I'm going to do the A. Okay, so it'd be A over the sine of 45. Okay, so let's cross multiply. We get A times sine of 95 equals 1400 times sine of 45. And both sides have sine 95. Okay, and there again, when you get this number, you're going to have to store it. Okay? So let's see, we'll put y'all in. 1400 times sine 45 divided by sine 95. So about 993.7. I guess that would be the feet. Okay. All right. Now what we're going to focus in on is just that the right triangle on the right side of the picture, right? Okay. So let me pull it out and draw it. So that would be this triangle, right? Okay. Now we know what the hypotenuse is. That's the 993.7. And then what else do we know on the 40 degrees? Okay. And now that's all we need to know to find out what this height is, don't we? Okay. Now, do we need laws of sine or cosine here? It's a right triangle, right? So we can use our right triangle ratios. So what are we going to use? Sine, cosine, or tangent here?
Sine, because
Sine.
sine.
Because you got what? From 40 degrees, that's what? Opposite and hypotenuse. Okay? So the sine of 40 will be equal to h over 993.7. And then we just cross multiply. Now, there again, when I push this in, I'm not going to push sine of 40 times 993.7. This is why I told you you should have stored that number. Okay? Which really and truly, it should be the last thing on the calculator, right? So you could just crunch answer times sine 40. Answer sine 40. Okay, I'll come over there and calculate it. 638.8, which probably is the nearest foot that they would ask. About 639 feet. Okay, now, another application with you. Alright, now, Yeah, this is the one I was referring to. Last year we did this problem, but they gave us an alternative formula because we hadn't talked about all of sine and cosine yet. So I may look up this formula. I think it has like a cotangent in it somewhere. But there's a formula that can actually do this a lot quicker if I just knew what it was, but I don't know. I'm going to try to look in last year's textbook and see if I can find it. Okay? But let's just try to do it with what we know. It's a lot like a ski lift problem. Okay, remember the ski lift problem we just did 2 examples ago? A lot like that one. Right, it says the cat needs to determine the height of a tree before cutting it down to be sure that it will not fall on a nearby fence. It's kind of like accident, you know, like accident. All right. The angle of elevation of the tree from one position on a flat path from the tree is h, which is equal to 50 degrees. So let me write that on my picture. So you probably want to draw that picture out on your paper. Okay, so we got h there. It's 50 degrees. And from a second position, L, which is 20 feet further, so this distance here is 20 feet. And so along this path, you have angle B is 40 degrees. Okay? So they want to know what's the height of the tree. So we're looking for that part of it. So let's see if we can figure out some stuff. Now here's my idea. All right, yeah, this angle here would be 130. Everybody follow that? Okay. And so what would be this top angle at C? Not the whole thing, but the smaller one. Yeah, it would be 10 degrees right there. Okay, so here's my idea. Let's use law of sines to find out what this distance is. So we can find that distance on the triangle. Now, that's not going to be my answer because we were looking for the height. But you notice that would be the hypotenuse of the right triangle. And if we knew what the hypotenuse was, then we could use the hypotenuse to find the height by using right triangle treatment. Okay? So it's a two-step problem there. You have to use laws of sine and then your right triangle treatment to do it. So let's see if y'all can help me set up a law of sines here.
20 over sine.
Right. So 20 over the sine of 10 would be equal to, so you want to call this right here x over sine of 40. All right, then we can cross multiply, so we get x times sine of 10 equals 20 over sine of 40. We divide both sides by sine of 10 after we pick up our calculator. Okay, so let's put it in. 20 times sine 40 divided by sine 10. This will be about 74.0 here. Now, is that what we're looking for? We're actually looking for the height. So let's see if y'all can set me up a right triangle tree. So from that 50-degree angle, let's just pull out the right triangle. So that's what we're looking for. This was 74.0. This angle down here was 50. So I think we can use what? Sine? The sine ratio. If you're looking for opposite, you have a hypotenuse. You can say sine 50 equals h over 74.0. So we'll say answer times sine 50. So that's going to give me the height here of about 56.7. All right, did y'all follow that okay? It's not, the first part of this lesson is not real tough. The tough part is going to come on Wednesday when we talk about that ambiguous case, that side-side angle. Okay, and that's where you get two triangles. You're going to love those two triangle problems because you get to do so much work. That's one that I'm worried about on our quiz about having time in those two triangles. I'm just to show you that next. All right. So not all of them, but you should be able to do all of them, but 5 through 8. Okay.